Hello, everyone. How are you doing? Welcome to the session. If you haven't already done so, please introduce yourself in the chat in the bottom right corner. Just give us a name and if you're comfortable, where you're from. I am Lukonde Mwila or Luke Mwila. Some people call me Skywalker. If you are currently, oops, just having a slight issue over here. Okay, cool. So we're just going to give it a few minutes before we actually kick off. I'm sure a number of people are still getting settled. In addition to that, they might be running just a few minutes late. But we do have a poll that is currently running. So please do check that out. It'd be nice to get an idea of your particular journey with managing multiple Kubernetes clusters. Maybe it is a brand new concept to you. Maybe you're completely new to Kubernetes as a whole. Whatever the case may be, please do check out the poll. It is on the bottom on the right as well, next to the Ask a Question section, and give us a response. All right, so far I can see that there are a number of people that are experimenting with managing multiple Kubernetes clusters. And we'll be delving into the details of what that actually entails in this particular session. I'm going to give it another minute or two before we actually start. It's nice to see some wide representation over here, seeing someone from Sri Lanka. We got India, Phoenix. I'm assuming that is Phoenix in the US. And we've also got Innocent from South Africa. You and I are actually in the same country. So that's great to see someone tuning in from South Africa. Herinda Fernando just asked a question. Please bear in mind that if you do want to ask a question, there is a section on the bottom that says ask a question. You can add any questions in there, but I'll talk about that a little bit more once we kick off with our session, and I'll just go over some of the admin or tips or etiquette just around making use of Crowdcast. All right, I think we can go ahead and start. So today's session is the first in a series that is going to be focused on managing, or rather operating cloud native at scale, or you could call it operating at scale. And so this is going to be a series that runs through the months of September and October. And today's session in particular is going to be focused on managing multiple Kubernetes clusters, in particular EKS, GKE, and AKS, and they are the most popular public cloud hosted clusters, and I'll be making use of Rancher to manage these. My name is Lukonde Mwila, or you can call me Luke. In case you're just joining now, I already introduced myself, but feel free to call me Lukonde or Luke. And I am a senior technical evangelist at SUSE, and I am part of the SUSE and Rancher community team. I am also an AWS container hero and have been a part of essentially just the cloud native space, DevOps and software engineering for probably about, I'm getting on about 5 years now. Started off with software engineering and then slowly transitioned more into DevOps and the cloud native space. Very passionate about sharing knowledge, and I am excited to be conducting this particular session and very keen to see what the key takeaways will be for you as individuals, especially especially in context to what stage of the journey that you're at with the cloud native space, and in this case of managing multiple Kubernetes clusters. So before we go any further, let's just have a quick look at what we'll actually be covering in this session. For starters, we're going to delve into the concept or the model of actually managing multiple Kubernetes clusters. So if you're new to that, that'll be a good opportunity for you to get up to speed on what it entails. And then we'll look at some things that you should be considering when it comes to multi-cluster management and doing this in an optimal way. We will then transition into a more hands-on approach of doing things and actually trying to implement the very things that I'll be touching on that you should be considering. And I will be doing that essentially using Rancher to manage EKS, GKE, and AKS, and also just demonstrate that full lifecycle management using Rancher. And then we'll explore some other important things like security, organization, visibility, and deployments. And each of these is an important dimension when it comes to managing multiple Kubernetes clusters. Lastly, in the last 15 minutes or so of the session, we'll have a dedicated Q&A. So that doesn't mean that you can't go ahead and ask and post questions in the meantime. So please feel free to do that, but they will be addressed right at the end. And so just a little bit of Crowdcast etiquette or tips. Please feel free to make use of the chat in the bottom right corner. It'd be great to see some engagement over there. Start off with introducing yourself and if you're comfortable, where you're from as well. If you do want to ask a question, there is a ask a question at the bottom right corner. So please do pop a question in there. Also have a look at what all has already been put. In the case that you want to ask a question that already exists, you can go ahead and just upvote it. In addition to that, be on the lookout for polls. So there's already one that is currently visible, and that is just so we can get an idea or some insight on your experience with multiple Kubernetes clusters. And if you're completely new to Kubernetes as well, that is totally fine. This is a safe space for that. Yes, I think I actually did see a question in regards to this as well. This session is being recorded and it will be available to you on demand afterwards. Okay, so as I shared earlier, this particular session fits within a series that is going to be running through the months of September and October, and I'm very excited. And we are essentially going to be focused on bringing you highly valuable content and material in regards to what it means to operate at scale or cloud native at scale. And the 4 different dimensions that we'll be exploring are cluster management, applications, utilization, and deployments at scale. Today's session is going to fit within the first dimension, which is cluster management at scale. So without further ado, let us now dive into managing multiple clusters. What does this actually entail, and what is it? Well, for starters, it is a strategy or a model. And so it is a means by which you, or a model in which you would be deploying your workloads to a Kubernetes cluster, a particular methodology. The alternative would obviously be to deploy your workloads to a single Kubernetes cluster. Now, if you're wondering, does that mean that I've been doing it wrong if I'm just working with a single Kubernetes cluster? Not at all. I'm going to defer to the response that we like to give, but not so, but we don't really like to hear it, and that is, it depends. This is all based on use cases as well as your respective objectives. Now, if you're working towards eventually benefiting from the list of items that are specified on the left-hand side over here, then you're probably already gravitating, you probably should be looking in the direction of multiple Kubernetes clusters. In the enterprise context, in many situations, you will find that an application consists of multiple environments, such as dev, staging or test, and production. In addition to that, some enterprises actually have multiple applications or workloads, and each of these has an environment. So you can imagine if you're essentially if you essentially deploy all of this onto a single Kubernetes cluster, you are going to be putting in additional work when it comes to trying to optimize that particular cluster for a host of different things. Let's take scalability, for example. Now, typical features that you'd be making use of would be the horizontal pod autoscaler, the vertical pod autoscaler, and cluster autoscaler. And so for the respective environments, you'd be trying to fine tune these just to reach the optimal kind of scalability that you want for your respective environments on the end workloads on a single cluster. Whereas the alternative is if you were to go with multiple Kubernetes clusters, you'd be able to distribute this, and even optimization on a single cluster for a specific workload or a specific environment would be much better, and you can increase redundancy and availability of your workloads. So multiple Kubernetes clusters definitely give you the one-up when it comes to scalability and availability. In addition to that, it is a really good practice to try and achieve environment isolation. So for example, if you've got both your production and your development environment running on a single Kubernetes cluster, it's not that that is a bad approach. It just means you're going to have to put in additional work in terms of creating that segregation or isolation, because you wouldn't want any operators or developers to deploy to the wrong kind of environment. And there's a higher risk of that when you're dealing with a single cluster. Something else that complements this would be application security. In some models, some teams or businesses opt to have multiple applications running on a single Kubernetes cluster. And just to my previous point, again, you'll have to be working additionally to make sure you have the right kind of segregation. So this kind of ties into that environment isolation as well. It's just that in this case, it would be application specific. The next point touches on what I mentioned earlier. With having a dedicated cluster for a particular workload or a particular environment, you can optimize that one to suit the needs of that particular workload or environment. And then a very important one would be the blast radius. If your workloads or environments are all running on a single Kubernetes cluster and something goes wrong with that cluster, the availability is essentially completely compromised for those workloads or environments. And lastly would be locking down access to a specific Kubernetes cluster or a specific environment. If you think about it, in most cases, you're going to be doing a lot of the heavy lifting when it comes to your development environment or your staging environment, which would mostly consist of testing. But no one should really be accessing your production Kubernetes cluster. That should be a flow coming out of staging. And so you want to lock that down to secure it as much as possible. And a multi-cluster model would definitely complement that. Lastly, something that we'll be looking at even further is this model complements the multi-cloud paradigm or model. And we'll jump into that a little bit later. So within the multi-cluster model itself, you have different kinds of approaches or ways to actually setting it up. For example, on the left-hand side over here, you'll see there is a cluster per application approach. And on the right, there is a cluster per environment approach. In my personal experience, I have only worked with the cluster per environment approach. And in this one, you would essentially have an entire cluster that is dedicated to a specific environment. With regards to the one on the left, you're essentially deploying a workload to run on a single Kubernetes cluster, an application workload rather. And on that cluster, you would then segregate the environments using namespaces, which are essentially virtual clusters. I will note as well that in some contexts, some teams actually opt to have, for example, application A and application B on a single Kubernetes cluster, or application C and application D on another Kubernetes cluster. That would still be a multi-cluster model. It's just that they're having additional applications on a single cluster. And so you might have already been picking up on this even as I explained it. This is something that is quite complex. And as much as it has a lot of benefits, which I touched on earlier, there are also a host of challenges that it introduces to your Kubernetes administration. So depending on the model that you opt for, you could run into issues when it comes to just the fact that you have different environments in the same cluster. That's something that you can do either with a single cluster or multiple clusters, but the risk remains the same, because if you have your production cluster, or rather your production environment and your development environment on the same cluster, you want to make sure that you have the right kind of isolation, especially with regards to prod, and ensuring that the tenants who are interacting with that cluster only have access to what they should be able to access. In addition to that, if you're going to have the approach where you have multiple applications on a single cluster, but with the multi-cluster model, then you're going to have to work additionally to have the right kind of isolation between these applications. And so this does add additional overhead in terms of management and administration, and it becomes complex. And one of the things that's very difficult to achieve, which will be a key thing that I'll be trying to touch on throughout this session, is alignment and consistency. And you want to make sure that if you're going with the multi-cluster model, you're able to achieve a certain standard in regards to security, organization, the management of the cluster infrastructure, et cetera, et cetera. But alignment and consistency are kind of the umbrella over over all the things that you'll want to achieve across the board. And that's not an easy thing to accomplish. And then, not to mention, this one might even be a bit of a no-brainer to some of you, especially in the context of making use of Kubernetes cluster in the public cloud environment. You have to keep an eye on your costs. They quickly rise up, especially if you're going to be making use of hosted clusters, because they are managing the control plane, and that does add an additional cost in regards to the on-demand costs that come with the node infrastructure and any additional load balancers, et cetera, that you're going to be running as part of your entire ecosystem. And so we're going to then translate that to the context of multiple clusters, but in multiple clouds. And so there is a benefit, especially in regards to Kubernetes when it comes to following the multi-cloud approach. And the reason for that is because Kubernetes is essentially infrastructure agnostic. Your workloads are all based on declared configurations, which are essentially infrastructure as code. And whether on-prem or in a private cloud or a public cloud, your application should essentially run the same. Now, granted, there may be some specific integrations, especially if you're going to be running it in a public cloud environment. But for the most part, as Nigel Poulton likes to say, Kubernetes is Kubernetes is Kubernetes. And Kubernetes is something that definitely helps you achieve workload and workflow portability in the context of the public cloud. And so you'd be able to distribute your application across different regions or applications across different regions and in different cloud environments because of that infrastructure agnostic nature of Kubernetes itself. And in addition to that, your operators aren't necessarily impacted because in terms of their workflow and Kubernetes development, because they will still be essentially interacting with the same kinds of manifest files or Helm charts when it comes to deploying Kubernetes applications. In addition to that, which is something that I mentioned earlier with regards to the benefits of having a multi-cluster model, is it helps you achieve redundancy and availability of your workloads. And so when it comes in the context of GKE, AKS, and EKS, these cloud providers actually take full control of the control plane. They ensure that it is highly available and that it is essentially optimized and secure. And so that is a great burden that gets lifted because you don't have to take responsibility over your control plane. You can then focus on optimization of what is essentially the worker plane as well as your application. In addition to that, there are several businesses that like to take advantage of cloud bursting. Now, this is something that would typically happen in the context of on-prem to public cloud or private cloud, but it can also happen in the context of the public cloud. You could essentially achieve greater scalability by leveraging the operational agility that the cloud environment gives you, especially when you can do that across multiple different public clouds. And something that is also beneficial in the case where you are running multiple workloads, you can basically cherry pick the cloud provider that you want to make use of if there are particular integrations that would be very fitting for the application that you want to run. For example, if there are certain services in Google Cloud Platform that you want to make use of for your application, you would then deploy it in that particular context. And if it's for another application that you want to have integrate with, whether it's AWS or Azure, you can then do that with that particular cloud provider. And this helps you also in terms of optimizing costs because you're not necessarily locked in to a particular vendor. You can actually just focus on achieving, making use of the best tools or what you feel are the best tools for your particular application. Okay, now, very important. There are a couple of things that you need to consider. If you think back, in light of the challenges that multi-cluster management introduces, these are 6 things that you really want to have on lock if you're going to go on this particular journey. Now, for starters, lifecycle management, if you're wondering what exactly does that mean, this is in particular context with Kubernetes clusters in the public cloud, like the ones that we're actually focusing on. So if you are hindered from carrying out full lifecycle management, then your operators are essentially going to have to be juggling between Kubernetes specific interaction or operation, which is what their workflow should be focused on, and having to delve into the specifics of a public cloud provider, knowing some of the ins and outs of whether it's AWS, Azure, or GCP. Whereas if there's a way that you can make use of a tool that gives you that full lifecycle management, and you essentially don't have to log into any one of those public cloud consoles, but just focus on having a single pane or a platform that allows you to still have that full lifecycle management, and that's a huge bonus. In addition to that would be security. And this is a huge topic, but something that we're going to be focusing on over here will be more of centralized RBAC, role-based access control. And in addition to that would be organization. And by organization, I mean within the cluster. How do you actually structure the way things are organized within a particular cluster for your applications? And it goes without saying that when you're going to be taking charge or looking after multiple Kubernetes clusters, you need to have visibility and insight on what's going on. That will help you when it comes to troubleshooting issues. It also complements security and a host of other things. And then lastly, we will look at an optimal way of deploying to these to multiple Kubernetes clusters. And if you see experience over there and you're wondering what exactly is that doing there, it seems like an odd one out. Well, the reason I put it there, and this is something that should be a thread throughout the rest of the session that we'll be focusing on as we go through the different items. Experience is touching on the platform, or just like I said, that single pane in which you interact with, or rather carry out multi-cluster management. You want to make sure that the tool that you're using is not getting in the way of what you're ultimately trying to achieve. And so in my case, I'm making use of Rancher, and that's what I'm going to be demonstrating. And I do want to show you how Rancher makes things very helpful and provides a fluid experience in carrying out each one of these particular dimensions. So we are going to start with lifecycle management of EKS, GKE, and AKS. Now, as I mentioned earlier, when it comes to these particular clusters, with Rancher, you can launch brand new clusters. In addition to that, you can import existing clusters, but it all starts with the cloud credentials. So that's something that we're going to focus on right now. I'm going to demonstrate, or rather just do a walkthrough of how you would import Kubernetes clusters into Rancher and start off, and it all starts with making sure you have the right cloud credentials, which will be stored in Rancher. So I'm going to switch to my browser over here, and I am in Ranchers. So you'll see at the moment that I only have one cluster, which is the local one. Rancher is currently deployed on an EKS cluster. That is where I am running it. And I want to import an EKS cluster. So over here, I'm in my AWS account. You'll notice that there are two EKS clusters. The one called Rancher is where my Rancher server is actually running. And I have another cluster called Alpha, which I want to import. And then in GCP, I have a cluster called Beta, which I'll be importing. And lastly, in Azure, I'm going to head over to Kubernetes services, and there should be a cluster called Charlie. So all these clusters were already provisioned prior to this session. And now I want to make sure that I can actually take full control of them using Rancher. And to do that, you would head over to Cloud Credentials. So I am going to go to Cluster Management and then head over to Cloud Credentials. And so you can see over here that I have the different credentials already created for AWS, for Azure, and for Google. But I'm going to show you how to do that. And we will start with GCP. So in the case of GCP, you would head over to I am an admin. And what you'd want to do is create a service account. And so with your service account, you would essentially be giving it permissions to, or essentially a role with specific permissions to carry out different functions as you would expect. And so this service account in particular is the one that is going to be used by Rancher. So you'd go through the process of creating a service account, as you can see over here, and just follow these different steps. So I'm just going to call this one SA. I'm going to continue. And I just want to show you the process of actually creating a role. So you can see over here, specifically Kubernetes engine admin, which is what we would want. So I've already created service accounts, so I'm not going to go through the process of creating them again. But when you have created a service account, you need to make sure that you create a key. And when you add your key over here, that will generate a certificate for you. And it would be, you can download the JSON configuration file, and Rancher allows you to upload that. So you would come to create, and in the case of GCP, you would select Google, and you can see over here, it would get the service account details from that particular JSON file. Now let's see the steps for Azure. In the case of Azure, you would actually be registering an application, but it all starts with Azure Active Directory, and then you would then proceed to app registrations over here. And you would create, you would register a new application. And once you have done that, so as you can see, I've got one over here. There is Azure AD Rancher, which I created. And then you would proceed to create a certificate or a secret. So somewhat similar to the process with GCP. And once you have done that, you'll be able to get a particular value. You'll also need to take note of the application or client ID over here, which you'll be providing to Rancher. So I'm going to go a step back and just show you with Azure. This is where you'd place the client ID, and this is where you would place the client secret. Of course, you would be giving it a unique name. Now, AWS is a little bit different. So you would be creating an IAM user. So I'm just going to head over to IAM over here. And you would just go through the process of creating a user, and it is pretty intuitive. So you just go to add user and follow the relevant steps. And you need to make sure that you select the access type programmatic access, because that will generate an access key ID and a secret access key for you. And that information is what you'll be providing to Rancher. But there is a caveat, and this is specifically in the context of importing an EKS Kubernetes cluster. What you will then need to do is EKS has a config map saved as AWS auth, and you will need to modify this file. Before Rancher can assume control of your EKS cluster, you will need to map your IAM user to RBAC, because Kubernetes does not internally store any user accounts. Its API server completely works based on role-based permissions, which is the RBAC system, and we'll take a look at that. And so you'll see over here that I have created, I'm essentially mapping my IAM user, which I created. In my case, it was Rancher EKS control Luke, and you would obviously specify your account ID over here. I've just swapped that out with AWS account ID. And then you need to add it to an administrative group. In my case, I've added it to system masters. And that way, when these credentials are provided to Rancher will be able to make use of those credentials in order to authenticate and also have the right permissions to take full control of the Kubernetes cluster. So I'm going to head to clusters over here, and I'm going to proceed to import and each one of the clusters that currently exists, which is Alpha, Beta, and Charlie. So my clusters are all spun up in Europe. So EU West 1 is the right region. And you'll notice over here, the cloud credentials field. It would actually be a very good model in the case that you're working with multiple clusters in a particular public cloud provider to have different credentials for those respective clusters. There's my cloud credentials that I've specified, and you can see over here, automatically Rancher is able to pick up on the different clusters that currently exist in that particular region. And so I want to register Alpha. So I'm going to proceed to do that. And that should take a minute or two. So while that is happening, I'm going to import Charlie and then Beta. Okay, these are the correct cloud credentials. You can see Charlie. Just waiting for that to come up. There we go. It's in progress. And lastly will be Beta. Righty. Okay, so I've already got my cloud credentials, but I also need to provide it with a project ID. And so for that, I'm just going to quickly head back to GCP and select the relevant project ID, which is this one in this case. Also, just a good tip, in the case that you have multiple clusters in the GCP environment, it'd be good to segregate these based on projects as well. So I'm going to select the region and looking at Europe West 1 and tell it to load clusters over there. And you can see there is the Beta cluster listed. I'll register that. Great. Now, while that last one is actually registering, you can see that already my Alpha and Charlie clusters are now fully in control by Rancher, and I can click on it over there. If you want to get a really cool view or overview of what's happening there, you can use the Cluster Explorer. And this gives a nice overview, and you can see over there, it shows you the total number of resources, the number of nodes, and any deployments that currently exist. It also gives us some really good metrics over here. These in particular are very important in terms of CPU and memory and keeping an eye on that. And obviously the number of pods that have been used, and you can also modify this. So this goes back to what I was talking about earlier about that lifecycle management. This single pane of glass allows an operator to just focus on a centralized approach to taking to managing multiple downstream clusters, and it simplifies things. Okay, so I've shown you importing, but what about actually creating these clusters? So I'm going to head over to cluster management. And this will obviously take a while for each one of these, probably about 15 minutes, but I'm just going to start the process and then we'll carry on with our session. So I'm going to start with Amazon EKS, and this will also demonstrate that full lifecycle management. And I'm going to call this one alpha test. I'm also going to, this will also be spun up in the same region, which is EU West 1. I'm making use of the same credentials. And you'll see over here, you can specify the particular Kubernetes version that you want. I'm going to specify version 20. In addition to that, you can configure the service role. You can customize it if need be. You can also add tags, which is a really good approach for just labeling your resources in a cloud environment. I'm going to proceed to configure the network. And then there's obviously the networking mode for your cluster, whether you wanted the API endpoint to strictly be publicly accessible, or if you wanted to just be private. In my case, I'm going to go with both public and private access to my cluster. And then over here, this is also very good. You can specify the kind of logging that you want. And this is really important, especially in the case of auditing. This will allow you to be able to track who did what on your downstream cluster in EKS. I'm going to also add additional logging for API, for the API endpoint, and that should be fine for now. And bear in mind that this will essentially the logs will essentially be pushed to CloudWatch in AWS. I'm just going to select a default launch template over here, and you can see the instance type that has been specified. Bear in mind that you can change this and modify it as you want. It gives you essentially the full list of EC2 instance types that you can have in your Kubernetes cluster. Bear in mind that there are some advised instances that you should be going with. So in my case, I'm just going to go with the default launch templates over here. And then lastly would just be the scaling requirements. So I want my desired size in terms of my worker plane. I want the nodes to be to try and stick to 2. And in the case that there should be any scaling, it should hit a maximum of 4. And I'll just call this alpha test node group. Great. And that cluster is now being provisioned. I'm going to proceed to show you the same with Azure. Yeah, this was Charlie, so I'm going to call it Charlie test. Proceed to configuration. You select your specific location. Let's go with West Europe. Configure the cluster. And so because these respective cloud environments have certain requirements, it will take a little bit of familiarity with how Kubernetes is configured in that respective cloud provider, but there aren't major differences. So it's nothing that you'll have to really worry about. So very important, you need to set the resource group, and I'm just going to call mine AKS RG. Also provided with an SSH key in the case that you want to be able to SSH into the instances. I'm not going to be doing that. And I will provide it with a DNS prefix as well. Call that, we can actually just keep it as AKS DNS. And I'm going to move on specifically to the node pools. You can provide that with a name. I'm going to go with the default. And again, this is all configurable. And based on whatever your particular requirements may be, I'm going to increase my node count to 2 nodes. And you can also specify the number of pods that you want on a particular node. And once you're done with that, you can go ahead and create. So I'm not seeing any errors. So that is provisioning. And so the steps are essentially pretty intuitive, even with regards to a GCP cluster. So that's the lifecycle management side of things. You've seen importing of these clusters, and you have also seen creation of the clusters, and we'll be interacting with them a little bit more. But for now, we are going to proceed to security. So if you think about the journey and how this would typically go, right now I am just an administrator inside of Rancher, and I have made sure that I've now adopted and created additional Kubernetes clusters. The next step is to enable or empower my team of operators to be able to engage with the cluster. So the next step is security, specifically in regards to role-based access control. And so with Rancher, you would essentially be centralizing that so that the Rancher server manages authentication. And so any users that want to interact with the downstream clusters would essentially have to authenticate with Rancher, and then Rancher will then proxy any requests from those particular tenants down to the downstream clusters. And the downstream cluster will then determine whether or not you're able to actually carry out the particular operation based on what you define in your RBAC policies. So like I said earlier, Kubernetes uses role-based access control to secure operations for the API server. It doesn't keep track or store user accounts. That has to be managed externally. And these are the 4 API objects that you would deal with in RBAC. You've got a role, which is used to determine the operations that can be carried out in a specific namespace. And you would then, so in that role, you would specify the different permissions, such as anyone that is attached to this role is able to, for example, create a deployment, is able to see pods, etc. in a particular namespace. You would then use the role binding object to attach that particular role and its respective permissions to a particular tenant or a particular service account. And service accounts are used by pods. And the same, it works essentially the same way for cluster roles and cluster role bindings. The difference is, and you have to be very careful with these, is that cluster roles are for cluster-wide permissions. So roles are specific to namespaces. Cluster roles are for cluster-wide permissions. And so this diagram over here essentially depicts what I'll be setting up now. You have teams of operators, and because those different operators will essentially want to interact with the downstream clusters, you're going to be making use of Rancher to manage authentication of those particular users, and you can also define the permissions of what they're able to do on the downstream clusters, as well as what they're able to do on the Rancher server. So I'm going to switch back to Rancher over here, and I'm going to head over to users and authentication. And I am now going to create a new user, and I will call him username OB1. Display name will be OB1 Nobi. Provide them with password. And then you can define the global permissions for this particular user over here, whether you want them to be a standard user or if they're going to be a restricted administrator, and it specifies what they'll have permissions to do. A restricted admin won't have control over the Rancher Kubernetes cluster itself or the server where Rancher is running, but they will have full control over all resources in all of the downstream clusters. A standard user, on the other hand, can create new clusters and manage clusters and projects, but only the ones that they've been granted access to. So I'm going to create a standard user over here. And so I'm going to log out and log in with that particular standard user. Just close all of this. And you'll notice that this user has no access to any Kubernetes clusters. And the reason for that is because I didn't grant them permissions for it. And so in order to change that, I would have to go back to the administrator. I'm going to grant this user access to the Alpha Kubernetes cluster. At that point, OB1 can then operate on that particular cluster. So I'm going to come here and I'm going to head to cluster management. And then I'm going to edit the configurations of the Alpha cluster. You'll notice over here, there is a section called member roles. And this is where you can add a member, and I'm going to add OB1. There are different types of roles. There is an owner who has complete control over all resources and what are also known as projects and namespaces, and we'll take a look at that a little bit later. Or you can have them just only take full control within a particular project, which is a grouping of namespaces. And so I'm going to make OB1 a owner in this case. And then I will save those changes. We'll log back in as OB1. And now OB1 has visibility of the Alpha Kubernetes cluster. You can see here, and OB1 can also check out the different nodes in terms of just the low-level details over there. You can have a look at the workloads that are currently running. If you click on workload over here, you can see all of the different resources that are currently existing on that cluster. And I'm just going to switch it to all namespaces, and they can see everything going on over here. And we'll delve into that a little bit more. But also very useful is the kubectl or kubectl shell. And so in the case that OB1 wants to carry out some particular kubectl operations, that can be done. This probably looks very small from your screen, so I'm going to zoom in. That was a bit drastic. The kubectl get pods in all namespaces. There you go. And this is just a really good example of how there doesn't have to be direct interaction in terms of OB1's part and having to access the kube configuration file. Even though it is something that can be downloaded through Rancher, OB1 doesn't have to have a copy of that configuration file on his local machine. He can manage the Alpha downstream cluster using Rancher. So I will close that. And I'm going to head back to the administrator view. All right, so we've taken a look at lifecycle management, and we've seen security as well. So our team of operators has the relevant access, or we know how to define permissions for them using Rancher. The next step is organizing the clusters that they have access to. And so typically, organizing of clusters is done with namespaces, and namespaces are virtual clusters. So if you think back to what I spoke about earlier, in some cases, some teams will opt to use a namespace for a particular environment within a Kubernetes cluster. And in other situations, namespaces may just be dedicated to particular applications in their entirety. But it's very good for division of access control and resource quotas as well. And tenants can have specific permissions to specific namespaces. Now, namespaces are Kubernetes native objects. On the other hand, there is a custom object that Rancher introduces, and these are projects. And projects are groups of namespaces. And these are handy because this way, if you think about it, if you have multiple operators who are working on different applications that are on the same Kubernetes cluster, you can essentially organize your cluster into projects. And that way, all of the namespaces for a particular application would fit within one project, and all of the namespaces for another application would fit within a project. This also makes things more efficient in the case where you want to deploy resources to all of to a group of namespaces that categorically fit in the same space. You can install resources at the project level, as opposed to having to install them namespace after namespace. So this saves time as well, but this definitely helps in terms of organization. And this diagram just helps in terms of understanding that. And as I mentioned earlier, there are different roles when it comes to projects. You can assign someone an owner role, and in an ownership role, they can essentially modify a project. So that would be adding additional namespaces or removing of namespaces, or who has access to that particular project, but they cannot modify the project name. That would be the only thing that they cannot do. However, there is another role, which is members, and members have complete access to namespaces. So owners have complete access to the project and modifying what it entails, as well as the namespaces at a lower level, and members only have access to namespaces. In addition to that, you can add custom roles or add read-only roles. In the case of read-only, they would only be able to have visibility of the namespaces in a project, and you can create custom roles to specify the kind of permissions that you want for particular users. So let's take a look at this in practice. So what I am now going to do is I'm going to head over to Cluster Explorer. I'm going to go to Alpha, and then I'm going to go to Projects and Namespaces, and I'm going to create a project. I'm going to call it e-commerce, because I will be deploying an e-commerce application. And you can also specify some details when it comes to this project. Remember, there are groups of namespaces, so this would be a really cool way of actually making sure that you optimize your cluster to have an efficient use of resources. So you can add resource quotas over here, and this would come in handy. You can obviously also do that at namespace level, and you can add labels and annotations. Now, in my case, I'm just going to create my project like this, but I will add labels to namespaces that I will create within the project. And so it is down here at the bottom. You can see project e-commerce, and I'm going to proceed to create a namespace called e-commerce, and I'll just call it e-commerce namespace. I'm going to add a label, which will be tier e-commerce backend. Add that label. Namespace. Oh, it says this namespace already exists, so let me cancel that. That's the project. Oh, right, that's because we have this namespace over here that is not part of a project, so I will delete that, because we want to make sure that we have a namespace within a particular project. And I'll now proceed to create it. Here. E-commerce backend. Oops, is invalid. Oh, that's because we have a space over there. There we go. Cool. So where is it? There we go. So it's right at the top now. So my project has been created, and I've created a namespace for it, and it'll become clearer why I'm actually creating this particular project and namespace, but I hope you're tracking with the particular flow and journey over here. And so something else that is really important, if I go to the namespace, you can have visibility of the different resources that have been created in there. And in addition to that, because remember, right now I'm logged in as the administrator, but what I want to do is I'm trying to enable or empower an operator. So I'm going to add a member. And so remember, members can manage the resources inside of a project, but they can't change the project itself. But I'm going to make OB1. What's happening there? There we go. Going to make OB1 an owner of this project, and so he'll have full access to the namespaces within that project as well. So if I log out, go back in as OB1, and so OB1 will now essentially be responsible for his or her particular or their particular team in terms of any workloads that get deployed to that particular project that they have access to. But remember, that OB1 still has permissions to also create additional projects. So now that we've seen just the general organization of projects and namespaces, it might feel a little incomplete because nothing's actually been deployed, but we will get to that. But at least we've seen the step of organization. And so the next thing is we want to have a detailed level of visibility. So there's visibility in the on the hand of tenants. So OB1 has access to see what's going on over there, but it'd be good to actually get some detailed metrics. And the way of achieving that is to make use of monitoring. Monitoring is what is the best way of actually achieving visibility and insight in Kubernetes. And there is a monitoring stack that you can easily install in Rancher, which allows you to install Prometheus and get a Grafana dashboard, and you can easily share that Grafana dashboard as well. And the reason why this is important is because it definitely helps out with troubleshooting. If you've done any kind of operation with Kubernetes, then you know that it is very important to have visibility and to be able to trace any issues that may go wrong in the cluster. In addition to that, having detailed visibility of, for example, metrics related to CPU or memory or custom application specific metrics, you can actually start to optimize things and fine tune them a lot better. And in the context of making use of clusters in the public cloud, this helps you with learning to optimize costs because things can get very expensive quickly. In addition to that, it also it gives you an edge when it comes to security because you'll be able to see, are there any resources running in my cluster that shouldn't be there? So let's proceed to install the monitoring stack. And for that, I'm still exploring Alpha, as you can see over here. If I go to Apps and Marketplace, there are a host of different popular stacks that would typically be installed to Kubernetes clusters, and I want to install the monitoring stack. And so you can see over here, this chart, it actually gives me a warning, and this is really good. This chart requires 4.5 CPU cores, but the cluster only has 3.4. And so this is also a good way to demonstrate how you can easily modify your cluster infrastructure. Instead of having to switch over to AWS, I can then just head over to my cluster over here. And for that, what I'm actually going to do is I'm going to add an additional node. So I'm going to edit my Kubernetes cluster. And I'm going to upsize it to, let's say, 5. I'm going to save that. So this will take a little bit of time. If you come to the Cluster Explorer, you can actually click on Nodes, and you can see over here that, so this is also a really good way to actually just keep track. So the nodes are still being provisioned. As they go through the process of being provisioned, they will essentially come up in the cluster, and then they will be tainted just so Kubernetes knows not to schedule any particular pods to those nodes as they still come up. And so this might take a couple of minutes. In the meantime, we can proceed with a different cluster. And so I will head over back to the administrator, and I'm going to find a cluster that has a decent number of nodes. Oh, looks like we're having some trouble with one of our clusters coming up, but we can see that our alpha cluster is currently updating at the moment, so the nodes are being provisioned. So I'm going to check out Charlie. And Charlie also has 2 nodes. Beta has 6 nodes, so this should definitely be sufficient. So I'm going to head over to Apps and Marketplace. I'm going to select the monitoring stack, but still insufficient CPU. So that will cause some issues. Hopefully all this switching has given Alpha enough time to finally upsize, and there we go. Perfect. So we got 5 nodes on Alpha. So I'm going to come to monitoring. You can see that warning has now gone away, and I'm going to install the monitoring stack. Bear in mind, this is completely configurable. It allows you to add the values that you would in the case that you were using Helm at at a CLI level, but I'm not going to be modifying anything. And I'm going to proceed to install. Great, and while that is happening, you can see it's going through the relevant steps and installing all the resources. We can head back to our slide deck, and now we will cover the last step that we want to make sure we have consistency or alignment of across our downstream clusters, and that would be to have an optimal approach when it comes to deployments. And so Rancher manages deployments using the Gitops model. If you're new to the concept of Gitops, it essentially brings together Git version control and operations and puts these 2 models together to allow you to have a single source of truth for your infrastructure. And so your infrastructure as code is stored in a Git repository, and with a GitOps model, you will have a Gitops tool that essentially does the job of watching a particular Git repository for any particular changes that may take place. And in the case that it detects changes, it will then deploy that infrastructure to a particular downstream cluster. And Rancher uses Fleet, which is an open source tool as well from the SUSE team. And these are the benefits of the GitOps model. It allows you to make use of infrastructure as code, which is great for creating immutable infrastructure. And that way you get to avoid any risks when it comes to configuration drifts in your infrastructure. In addition to that, you get to actually carry out code reviews for infrastructure, which is declared, in this case, would be manifest files. So it is based on a declarative paradigm or model, as you can see over there, and it also just gives better observability, and it is self-documenting because all of your infrastructure is now in source code. And so what we're going to be setting up now over here is Fleet is already running in Rancher. And so I will now proceed to use Rancher to deploy a mock e-commerce application to my alpha cluster in EKS. And just so you have an idea of what this e-commerce application is, on the left-hand side, you can see over there, it consists of 3 microservices or 3 containers. The 2 on the right side are a products and an orders microservice, and they are fronted by an API gateway and GraphQL. So these are going to be deployed to specifically to an e-commerce namespace. And they are going to be isolated, making use of a network policy to make sure that they can speak to each other, but no tenant outside of that can interact with any of these pods once they are created in the cluster. In addition to that, I will also deploy a simple Node.js application, but that will be deployed to the default namespace. So I'm going to head back to Rancher over here. You can see all the logs, and Prometheus and Grafana should be up and running now. So I will close that. You can see the cluster metrics are currently still loading, but we'll be able to see get some really good additional insight. And you can see over there. So that provides you with much better detail and insight for the metrics of your cluster. And if you do want to see the Grafana dashboard, it provides you with a link over here, which is great. And this is a link that you can obviously also share with the relevant personnel that would need access to this dashboard to get visibility of the metrics in your respective cluster. Right. What we're interested in now is the continuous delivery model to our downstream cluster. And so you can see here, I've already got a Git repository that has been added. And so just to take you through the process, I will delete that. I'll proceed to create it. And so give it a unique name, e-commerce, and I'm just going to get my repository link from there. This is a public repo, so I shouldn't have any issues with regards to permissions. And obviously you can set up the relevant credentials to authenticate with GitHub when in the case that you are keeping a private repository, which will probably be the case in the enterprise context. You would then specify the branch that should be watched, as you can see over there. And I'm going to scroll down over here. And very important, this application, as I said, consists of GraphQL, orders, and products microservices. And each one of them has a raw manifest folder, which specifies the resources in a YAML file. And I won't go through each one of these in detail because it will take a little bit of time. And there is a folder as well dedicated for the network policies to make sure that we have that right kind of segregation and make sure that only e-commerce related pods can speak to each other. So what we actually want to do is head to Rancher, and you'll see you can specify the paths over here. Now you can specify a Helm chart as well. In my case, I'm pointing to specific manifests inside of my repository. And so I'm going to put in GraphQL, and this would be, I want Rancher to look inside of the raw manifests. So add that path. In addition to that, I will do the same with orders, products, and network policies. orders. Change this to products. And network policies. Great. And then there is choosing the cluster that this should be deployed to. And this is great because you can actually specify different clusters, or you can specify all clusters. In my case, I want to specifically deploy this to Alpha because that is where I created a project with a specific namespace. And I will put in over here the target namespace. And I will create that. And so you can actually track this to see what's happening. And you can see the progress going on over there. You can see the network policy has been created. One of the deployments has been created, and so on it goes. In the meantime, I'm going to head back and I'm quickly going to create another Git repo, and this one will be Express test. And I'm going to get this repository. I'll put it there. Again, this is also a public repository. And I'm not going to specify any target namespace for this one. We'll pretend that a team of operators is essentially just wanting to carry out a proof of concept. And it should look for manifest inside of the manifest folder, if I remember correctly. Yep. So there's a pod and a service that should be deployed from there. And in this case, I want to deploy this to the beta cluster, which is my GKE cluster. I'm going to click create. So in the meantime, while that's coming up and running, we can see over here that all of the resources have been created as expected. And so we will check to see if our application is available for us. In the meantime, Express test is still coming up. So the service is still being provisioned. That might take a couple of minutes because it's creating a load balancer. But I will head over to Alpha and then go to service discovery, because a service was created for the e-commerce application. So I am specifically looking for e-commerce, and you can see over there. And the GraphQL is essentially the GraphQL microservice is the API gateway. So that is the endpoint that I'm interested in. The rest are all cluster IPs, as you can see over there in terms of their type of services, whereas this one is a load balancer. So I can actually just click on this. And looks like we are having an issue. I wonder if it is a case of it still being provisioned. In the meantime, let me go and have a look at Express test to see if that is ready. So I will head over to beta, because that is my GKE cluster. I'll go to service discovery, and that is listening on port 8080. Great. So we can see over here that I'm actually able to access my Node.js application, but the relevant endpoint is actually test. And as you can see, I get the feedback that I want, which is simple Node.js app working. So you can see even the process of actually just deploying an application to a downstream cluster is completely streamlined. I am surprised that this isn't working as expected in terms of the AWS application, but I don't want to dive into debugging that particular issue. I will then switch back to our slide deck. And that is it in a nutshell. We explored the different dimensions in which you would essentially want to make sure you have consistency and alignment. We're now going to proceed to the Q&A section and spend a couple of minutes over there. And please just note that if your question doesn't get answered in this particular session, we have a record of all of the questions that have been asked, and they will be addressed. I also want to take this opportunity to let you know that you can interact with myself and other cloud native practitioners inside of the SUSE and Rancher community. You should see a green button at the bottom over there which says join the community. please do sign up. It's completely free, and there's a lot of great material and resources over there, such as on-demand classes, technical articles, all to help you and equip you, because this journey is a difficult one, but it goes a lot easier when you're doing it in community, and that would be a great place to actually practice that. So I'm going to stop sharing my screen now, and I'm going to take a look at the questions that we have over here. Okay, so I see the most upvoted question was if the event will be recorded, and so that has actually been answered. I can see over there, and I mentioned right at the start, the session is being recorded and will be available on demand. Next up, I can see, is there a Terraform provider for Rancher that supports the configuration walkthrough being shown? Can I do what is being done in the video with Terraform? That is an excellent question. In fact, there's actually going to be a challenge going out, and I will be providing the source code. I used Terraform to provision each of the initial clusters that I imported. And so I will share that, and you can definitely set that up. There is also a Rancher provider as well. But in this case, the challenge that will be going out will specifically be to provision a cluster using Terraform, but then proceed to install Rancher on it. So yeah, the resources will definitely be available. Okay, I see another question over here. Location of slides for this series. So these resources will be provided and made available to you as well. If you would like access to the slide deck, I'm sure we can arrange that. But remember, most importantly, is the session is actually recorded, so you will have access to all of this on demand, even after this session comes to an end. Right. Any particular reason not to include on-prem clusters? That's an excellent question. So like I said right at the start, this is not a situation in which managing multiple Kubernetes clusters in, specifically in a public cloud environment as the only way of doing things or a silver bullet, nor is it the optimal one. Rather, it comes down to use cases and what your objectives are. You can have a hybrid approach where you're making use of on-prem as well as cloud, or even just making use of on-prem if that's what would suit your particular requirements. And please stay tuned. Like I said, this is just the start of the series. There's a lot more coming up, and these are some of the things that we'll be touching on as well. Okay. Hi, I understand that this masterclass is about EKS, GKE, and AKS, but how about importing from other cloud providers, for example, IBM? That's an excellent question. And Rancher does allow you to import other cloud-provided Kubernetes clusters, but bear in mind that Rancher at the moment only offers full lifecycle management of EKS, GKE, and AKS. So the kind of experience that you'll get with these particular clusters is not the same that you would get with other clusters when you import them. In addition to that, there may be cases in which you just need to add additional configurations. What version of Rancher are you using for the demo? Excellent question. I am using Rancher 2.6, the brand spanking new one, the one I'm calling the 21st century convertible with an amazing UI. So please do go ahead and download that. I encourage you to check it out. I think you would agree with me that it definitely enhances the experience. Is there a way to automate all of this rather than use the GUI? That is a very good question. So I'm assuming you are probably speaking specifically about if there's a way that you could actually just declare all of these things and have all of it spun up. So the whole point of making use of Rancher is to actually make life a little bit easier. So having a GUI provides a different kind of experience in terms of visual representation and visibility of what's going on, especially in the context of Kubernetes, because as it is, the declarations are some of the things that contribute to complexity when you have to go through all of that. And what Rancher is essentially trying to do is to take away the burden that comes with the hefty administration of managing multiple Kubernetes clusters. So the goal is to provide you with something simple to achieve your main objective. So you shouldn't be spending a lot of time essentially trying to work with configuration files with Rancher. But I will say as well, like it's just not something I touched on, but you can automate a number of the things that I was doing. if you check it out yourself, I encourage you to do that. You'll see that there are a lot of options for you to actually provide custom configurations with YAML files, and you can definitely do that as well. And perhaps just store that in a repository, and it'll make life a little bit easier for you. But that was a great question, Michael. How can I use Rancher to migrate a cluster from EKS to GKE? Is it possible using backup and restore? So it is possible to backup and restore clusters, but what you're actually talking about is workload portability. So let's see if I'm correct, because you're trying to see cluster.f.e from EKS to GKE. So these are two separate clusters. So I'm assuming here, and please, if I'm not answering this correctly, Natasha, I think is your name, please do let me know, and I will try to change my answer appropriately, or accordingly rather. And so if you're actually talking about workload portability, that kind of speaks to what I shared earlier as well, with the benefits of Kubernetes being infrastructure agnostic. The challenge you might run into is if you've got a lot of integrations, for example, on the AWS side of things, since you want to move from EKS to GKE. However, if it's a situation where you haven't had a lot of integrations or tie-ins and sort of locked yourself into that particular ecosystem, then it's a case of actually making use of something like Rancher Fleet to change the cluster, the downstream cluster that you want to move your workload to. So yeah, but I think that I hope I answered that correctly. Let's see, just if I want to change the cloud provider, for example. Okay, yeah, that's definitely a workload. That seems more like workload portability. And Rancher can definitely help you with doing that. You would essentially change your source using Rancher Fleet to the particular cluster that you want to now move your downstream, that you want to have as your downstream cluster. Backup and restore is a little bit of a different topic, but that's also something that you can do with Rancher. Does Rancher make any changes to the K8 clusters when they are imported into Rancher? For example, would anyone that doesn't use Rancher manage the cluster know that there is a Rancher managing it? Well, yes, there is an agent that is running on the cluster. So if there's an operator who is interacting directly with the cluster and they have visibility of the pods and the daemon sets, then they would have access to see that there is a fleet agent running on it, and there is a Rancher specific agent and the region cluster agent. And the reason for that is that agent is what actually communicates with the Rancher server to make sure that there is basically, well, for one, requests coming from Rancher are proxied down to that cluster, and just essentially all the relevant management operations that are coming through from that end. How different is Fleet from the cluster API? So if you're referring to the cluster API server, that's a component in your control plane. And so that's kind of the hub or the central place for all the CRUD operations in the Kubernetes cluster. Whereas Fleet, on the other hand, is a Gitops tool. And so Fleet is a separate platform that does run on the Kubernetes cluster as well. And it can be installed apart from Rancher. But its main job, Fleet's main job, is actually just to pull the resources from a particular Git repository and then make sure that those are deployed to your downstream cluster. So Fleet will be communicating with the API server of a downstream cluster. Is it possible to add clusters on local host, bare metal, and or other homespun clusters such that they interoperate with AKS, EKS, GKE clusters? Okay, I'm not sure I entirely understand your question here. Okay, I'm not sure if you're able to just provide a bit of clarity for me there, Toby, but I will come back to your question. I'm testing key cloak integration with Rancher. How do I set up cluster access via key cloak? So this is also another thing that I'll probably have to explore. I don't have much experience with that, but again, I'm not just saying this for the sake of trying to get you to join the community. It'll also be a good way for us to engage with this, and there are definitely a host of other practitioners that can help with addressing some of these issues. And like I said, if I don't address it tonight, I will definitely, well, it's tonight on my end, but this is morning for some other people. I will definitely be addressing it in future as well. But this is a good question. Thank you for asking it. Would the projects and namespaces be merged to the main Kubernetes branch? Okay, so there might be a little bit of confusion over here. Projects and namespaces are specific to a cluster. Now, namespaces are Kubernetes native. They are virtual clusters within a cluster to provide segregation. Projects are groups of namespaces. And so your workload would then be deployed to a specific namespace, or you can deploy your workloads to different namespaces. And those namespaces, remember, fall within a project. So you typically won't actually have to specify, you won't have to specify a project in your application if that's what you're speaking about, because you use the term main Kubernetes branch. So I'm assuming you're talking about an actual repository that has declared manifest files or a Helm chart. So I hope that provides some clarity. So you could just be specific about the namespace that you want your workload to be deployed to. Migrating from 2.5.8 to 2.6, is it seamless? Any plan for upgrade video? Well, for an upgrade video, I will say stay tuned. I have not carried out the particular upgrade process myself, but there is documentation on how to upgrade Rancher. So that is something that we can also try to provide for you. Like I said, you'll still have access to this particular session on demand, but also you'll still be able to see responses in the chat. So I'll try to make sure that I provide some other answers to questions that have been specifically answered in the chat there as well. But that is a good question. Okay, so I will come back to Toby over here. Like I said, I would have noticed there haven't been any modifications to the question itself. So I'm going to wait on you, Toby. I hope you're still on the call. And then maybe you can modify that question for me. The last one would be from Matt. Is there a recommended way to deploy a Rancher server on Next to RKE to cluster on vSphere? And if so, what should that deployment look like? So again, this is definitely going to be, in terms of the underlying cluster that you're going to go with, whether in my case, I was using EKS, but if you're going to go with RKE2 or RKE1, the main recommendation is to have a highly available cluster and to make sure that that Rancher is, apart from it being installed in a highly available cluster, that there is no other workload running on that cluster. It should be dedicated for the Rancher server. But if you really want like some specifics of actually running, or rather installing Rancher on RKE2, that is something that we can also chat about later in the community. Okay, so the last question is from Toby. I'm just going to give it a bash, and I'm going to assume that you're maybe asking if it's possible to incorporate, or rather manage all of these clusters from Rancher, in which case it is possible to manage bare metal clusters as well as on-prem clusters. But when you say interoperating with AKS, EKS, and GKE clusters, that's starting to sort of become more of at a workload level, because if you're talking about those applications talking to running on those respective clusters, talking to each other, and that is something that is possible in the same way that it would work even outside of a Kubernetes context. Obviously, here you have to think about how that translates to how your applications are configured, and networking considerations in that context as well. All right, so that is all of our questions, and I'm actually going to call it. Once again, thank you so much for attending the session. I definitely hope it was beneficial to you. Please remember the session has been recorded, it is available on demand, but most importantly, click the green button at the bottom, join the community. The conversation doesn't have to end here. You can interact with myself and a host of other cloud native practitioners. There's more great material that is available for you to make use of in the community, and be on the lookout. There is a challenge that is going to be coming. I'd love to see you spinning up Kubernetes clusters in these hosted providers, and to see if you can actually also install Rancher on one of them. It doesn't have to be EKS, it could be on GKE or AKS. And let's see what application you can deploy there. Feel free to make use of the ones that I shared in this session. They are public repositories, and a lot of details will be made available for you tomorrow as well. Goodbye, everyone, and enjoy the rest of your evening or day, depending on where you are tuning in from.